To the pilots of the Soviet PVO Streny, the air defense forces responsible for guarding the vast airspace of the motherland, the American arsenal was a source of constant paranoid study. By February 2nd, 1970, the technological race had reached a fever pitch. Soviet intelligence officers and MiG-25 pilots spent hours analyzing the silhouette of their primary adversary in the high-altitude interception game, the Convair F-106 Delta Dart. This was not just another fighter jet. In the classified briefings held in the concrete bunkers outside Moscow, the Delta Dart was described as the ultimate interceptor. It was fast, exceeding Mach 2. It was armed with nuclear-tipped Genie rockets. But what truly unsettled the Soviet analysts was not the speed or the weaponry, but the machine's brain. The Americans had equipped this aircraft with the MA-1 electronic fire control system, a primitive but revolutionary computer that could fly the jet, intercept a target, and fire weapons with minimal pilot input. To the Soviet mind, grounded in a philosophy of rigid ground control and manual piloting, this was a terrifying leap toward the concept of the manless machine. They feared a future where American jets did not need pilots at all. On a freezing winter morning in 1970, over the desolate plains of Montana, that fear would manifest in a way that defied every law of aerodynamics and logic known to aviation history. The setting was the remote, snow-dusted expanse of the American Northwest, a landscape that mirrored the harsh winters of Siberia. High above the cloud layer, Major Gary Faust of the 71st Fighter Interceptor Squadron was strapped into the cockpit of Delta Dart, tail number 580787. He was not thinking about Soviet intelligence or the geopolitical chess game playing out in Vietnam or Berlin. He was focused on survival. Faust was engaged in a complex air combat maneuvering training mission, a dogfight simulation designed to push both man and machine to their absolute breaking points. His opponent was his wingman, waiting to pounce. The F-106 was a delta-wing aircraft, a design that offered incredible speed but could be unforgiving at low speeds or high angles of attack. As Faust pulled the stick back, attempting a high-G vertical reversal to get a firing solution on his adversary, the laws of physics snapped back. The aircraft shuddered violently, the nose wandered, and the smooth airflow over the massive delta wings detached. In a heartbeat, the sleek interceptor ceased to be a flying machine and became a falling brick. The jet entered a flat spin. For a fighter pilot, a flat spin is the stuff of nightmares. Unlike a normal spin where the nose is down and recovery is possible, a flat spin traps the aircraft in a horizontal rotation, falling straight down like a maple seed. The centrifugal force pins the pilot against the side of the cockpit. The altimeter unwinds with terrifying speed. Faust fought the controls. He slammed the throttle to idle. He deployed the drag chute, a desperate measure to pull the nose down and regain airflow. The chute deployed, caught the slipstream, and instantly failed, ripping away from the fuselage. The aircraft continued its nauseating rotation, falling from 35,000 feet to 15,000 feet in seconds. The horizon whipped by in a dizzying blur. Sky, ground, sky, ground. Inside the helmet, the sound of the pilot's own breathing was drowned out by the stall warnings and the groaning of the airframe. He had tried everything. The manual was clear. If the aircraft could not be recovered by 15,000 feet, ejection was mandatory. To stay any longer was suicide. At 15,000 feet, Major Faust made the decision. He grasped the ejection handles on the seat. In that fraction of a second, he was admitting defeat. He was abandoning a multi-million-dollar asset to destruction. He initiated the sequence. The canopy blew away with a deafening roar of explosive bolts. The rocket motor under his seat ignited, slamming his spine with nearly 20 Gs of force, blasting him out of the cockpit and into the freezing Montana air. This is where the story should have ended. In 99.9% of aviation accidents, once the pilot leaves, the aircraft is dead. It is a chaotic mass of metal obeying gravity, destined to impact the Earth in a fireball. The Soviet observers monitoring American crash reports would have expected a standard crater. But as Gary Faust drifted under his parachute, swinging in the cold wind, he looked down. He expected to see his jet tumbling toward the snowy fields below. He expected the explosion. Instead, he saw something that made no sense. Below him, the F-106, the machine that had just tried to kill him, was no longer spinning. The sheer violence of the ejection, the sudden shift in the center of gravity as the pilot and seat left the nose, combined with the rocket blast pushing down on the cockpit, had done exactly what the pilot could not. It had shoved the nose of the jet down. The airflow reattached over the wings. The lift returned. The Delta Dart, now empty, leveled out. The engine, still running at idle power, hummed steadily. Faust watched in disbelief as his aircraft, the 580787, stabilized into a perfect, gentle glide. It didn't crash. It didn't roll. It simply began to fly. High above, Faust's wingman, Major Jim Lowe, screamed over the radio, "Gary, you'd better get back in it." It was a dark joke, but the reality was terrifying. The aircraft was now a ghost ship. It was carrying live missiles. It was fully fueled. And it was flying with a robotic precision that seemed almost conscious. To an outside observer, or a Soviet spy satellite capturing the trajectory, it would look like the ultimate weapon, a drone fighter operating with total autonomy. The cornfield bomber, as history would come to call it, had begun its impossible journey. But for the men in the air and the radar operators on the ground, the mystery was just beginning. Where was it going? And what would happen when this 19-ton missile met civilization? If you are enjoying this dive into Cold War history, please take a moment to subscribe to Cold War Impact. We uncover the forgotten secrets and the high-stakes mysteries of the era that defined our modern world. The radar operators at Great Falls Air Defense Sector stared at their scopes. The blip representing Faust's jet should have disappeared. It should have merged with the ground clutter. Instead, it remained steady, tracking slowly across the screen, descending gradually, like a predator stalking prey through the long grass. This wasn't just a loose aircraft anymore. It was a technological anomaly. The Americans had spent billions trying to perfect autopilot systems, but this was accidental perfection. The plane was trimming itself. As the fuel burned off and the weight changed, the natural stability of the delta wing, freed from the interference of a human pilot, found its own equilibrium. For the Soviet analysts who would later review the intelligence reports of this day, this incident would become a case study in confusion. They often assumed American failures were actually cover-ups for secret tests. Was this a test of a remote control interceptor? Was the ejection a staged event to test survivability while the plane continued the mission? But on the ground in Montana, there was no conspiracy, only panic. The sheriff's office began receiving calls. Farmers looked up from their winter chores to see a sleek, dagger-like shape descending silently toward them. It had no canopy. The cockpit was a gaping hole. There was no pilot. Yet, the wings were level. The aircraft was heading toward the small town of Big Sandy. The F-106, a machine built to kill Soviet bombers at twice the speed of sound, was now drifting at 175 knots, looking for a place to land. High above the frozen landscape, the laws of probability continued to crumble. Major Jim Lowe, flying the chase plane, watched in a stunned silence that bordered on reverence. He was witnessing a phenomenon that defied every technical briefing he had ever attended. The empty F-106 Delta Dart was not merely falling. It was hunting for a landing strip that did not exist. From the perspective of a Cold War adversary, this moment represented a terrifying unknown. If a Soviet Tupolev pilot or a KGB station chief had access to the live radio frequencies of the 71st Fighter Interceptor Squadron at that exact moment, the panic would have been palpable. The transmission traffic was chaotic, breathless, and filled with a specific kind of American urgency that usually signaled a nuclear alert. But the words didn't fit the standard codes. They were talking about a riderless horse. They were discussing a 19-ton interceptor that was navigating with the smooth, calculated grace of a veteran pilot, yet the cockpit was visibly empty. To the Soviet strategic mind, paranoid about American technological supremacy, this scenario smelled of a deception. Since the late 1950s, the Kremlin had feared the development of the automatic battlefield. They knew the Americans were experimenting with drone technology, with the Ryan Firebee and the early reconnaissance drones intended for Vietnam. But those were clumsy, fragile toys compared to a Mach 2 interceptor. If the Americans had developed a system where a frontline nuclear-capable fighter could recover itself from a catastrophic spin, stabilize, and navigate autonomously after the pilot had ejected, the balance of power had shifted overnight. It implied a level of cybernetic sophistication that Soviet computer engineering, lagging years behind in microprocessing, could not even comprehend. Back over the Montana plains, the ghost plane descended through the grain belt. The altimeter in the empty cockpit unwound past 2,000 feet. The engine, a Pratt & Whitney J75 turbojet, continued to cycle at idle power. It was chugging along, providing just enough thrust to maintain a shallow glide slope, preventing the aircraft from stalling into the ground. Major Lowe, circling above, considered his options. The rules of engagement for a runaway aircraft were clear. If it threatened a populated area, it had to be destroyed. But the F-106 aircraft was expensive, a critical asset in the Continental Defense Shield. More importantly, the trajectory was shifting away from the town of Big Sandy. It was heading for the open farmland, a patchwork of white snow and dormant winter wheat. The descent was eerie. There was no desperate struggle, no erratic wing wobbling. The aircraft simply lowered itself toward the earth, as if guided by an invisible hand. The ground effect, a cushion of air that builds up between the wings and the ground at very low altitudes, began to take hold. For a delta-wing aircraft, this effect is pronounced. The compressed air trapped beneath the massive triangular surface acted like a giant spring, gently arresting the descent rate. A Soviet engineer analyzing this later would have been baffled by the sheer luck of the aerodynamics. The F-106 aircraft was designed to be unstable to increase maneuverability. It should have rolled over. It should have pitched down. But the trim settings, left in the takeoff position during the struggle to recover the spin, were perfectly balanced for this specific speed and weight. The contact came at a place known locally as the Masterful Cornfield, though it was technically an alfalfa field covered in hard-packed snow. The aircraft did not crash. It arrived. It touched down with a gentleness that would have made a commercial airline pilot jealous. The landing gear was retracted, so the jet landed on its belly. But the F-106 aircraft carried drop tanks, large external fuel reservoirs slung under the wings. These tanks hit the snow first. In a violent crash, these tanks would have ruptured, igniting the remaining jet fuel in a massive fireball. But the angle was so shallow, and the snow was so slick, that the tanks acted like skis. The 19-ton fighter jet became a high-speed sled. It hissed across the frozen field, kicking up a rooster tail of white powder hundreds of feet into the air. It slid for hundreds of yards, carrying its momentum with terrifying efficiency. It crossed a rock pile. It sheared through a barbed wire fence, snapping the posts like matchsticks. The noise was not an explosion, but a long, tearing screech of aluminum against ice and earth. Finally, friction won. The aircraft slowed, drifted slightly to the right, and came to a halt in a gentle bank of snow. Silence returned to the field for exactly 3 seconds. Then, the sound that would haunt the local sheriff for years began. The engine was still running. The air intakes of the F-106 aircraft, now resting just inches above the snow, were still sucking in oxygen. The compressor blades were still spinning. The jet was resting on its belly in the middle of nowhere, appearing for all the world like a wounded beast panting in the cold. Sheriff's deputies and local farmers were the first on the scene, their trucks skidding on the icy roads as they raced toward the plume of snow. They expected carnage. They expected to find charred wreckage and the gruesome remains of a pilot. What they found was a scene from a science fiction movie. The aircraft was intact, perfectly intact. The grey paint was barely scratched. The US Air Force markings were crisp and clear. The only thing missing was the canopy. As the sheriff approached the machine, cautiously, hand near his holster, he felt the heat radiating from the tailpipe. The snow around the rear of the fuselage was melting, turning to slush. The jet was vibrating with the power of the idling engine. But the most chilling detail was inside the cockpit. The sheriff climbed onto the wing, fighting the slipstream of the intake, and peered into the open hole where the pilot should have been. The seat was gone, blasted out hours ago. The instrument panel was glowing. The radar scope, the heart of the MA-1 fire control system, was active. A bright green sweep line rotated rhythmically around the circular screen. Beep, beep, beep. The radar was still searching. Lying belly down in a Montana field, immobilized and pilotless, the aircraft was still hunting for Soviet bombers. It was tracking targets. It was performing its mission with a relentless mechanical loyalty that transcended the need for a human operator. To the gathered crowd, this wasn't a miracle, it was a monstrosity. It felt wrong. A machine shouldn't be this alive without a soul inside it. The sheriff turned to his deputy, his voice barely audible over the whine of the engine. "How do we turn it off?" They didn't know. No one knew. The cockpit was too high off the ground for a normal person to reach the throttle comfortably while standing on the slick, curved wing, and the fear of the ejection seat rockets, even though the seat was gone, the framing remained, kept them back. For over an hour, the F-106 aircraft sat there, idling, melting a hole in the snow, waiting for orders that would never come. The scene was surreal, a pinnacle of Cold War aerospace engineering, capable of Mark II flight and nuclear war, parked in a farmer's field like a tractor left running during lunch. From the perspective of the distant enemy, this soft landing was an even greater puzzle than the flight itself. When reports eventually filtered back to the intelligence directorates via press clippings and intercepted communications, the confusion deepened. How could an airframe survive a belly landing with such minimal damage that the radar kept working? Soviet aircraft were built like tanks, rugged and heavy, but their avionics were delicate. Vacuum tubes shattered, radars misaligned upon hard landings. The American machine appeared to be indestructible. This resilience hinted at a manufacturing quality and a structural integrity that the Soviets were struggling to match. If American jets could land themselves in fields and remain combat operational, what chance did the Soviet Air Force have in a prolonged war of attrition? But the true mystery was just beginning. The recovery crew from McClellan Air Force Base was en route. They expected to bring cranes and flatbed trucks to haul away scrap metal. They had no idea that they were about to participate in one of the most bizarre engineering autopsies in history. The question wasn't just how it survived. The question was, what had the computer actually done during those final minutes of flight? And why, when the engineers finally cracked open the flight data recorder and the radar logs, would they find parameters that shouldn't have been mathematically possible? The cornfield bomber had a secret. The landing wasn't just luck. It was a sequence of events so precise that it suggested the machine had adjusted its own trim in response to the changing air pressure, a capability the F-106 aircraft was not supposed to possess. The silence that finally fell over the Montana field was heavier than the noise that had preceded it. A brave technician from the nearby base, guided by radio instructions, had shimmied up the sleek, freezing flank of the F-106 aircraft. He reached into the open cockpit, his breath pluming in the cold air, and pulled the throttle back to the cutoff position. The J-75 engine shuddered, whined, and finally died. The green sweep of the radar faded to black. The beast was asleep. But for the Soviet observers attempting to piece together this incident from afar, the silence was where the real anxiety began. In the Kremlin's strategic assessments, an aircraft crash was a binary event. The asset was either operational or destroyed. A belly landing on frozen earth, even a gentle one, usually meant a twisted airframe, snapped spars, and avionics reduced to powder. They expected the Americans to bring in bulldozers, to crush the classified remains and bury the evidence. They did not expect what happened next. A recovery team from the Sacramento Air Material Area arrived on the scene, not with demolition charges but with wrenches. They were not there to bury the plane. They were there to disassemble it. To the disbelief of the onlookers, the initial structural assessment revealed something impossible. The Delta Dart, a supersonic interceptor built for the fragile environment of the stratosphere, had acted like an armored tank. The damage was insultingly minor. The skin on the underside was scraped. The intermediate launch doors were torn. The radar antenna required replacement. But the main wing spars, the structural spine of the aircraft, were unbent. The fuselage was not warped. The geometry of the plane remained perfect. This revelation sent a chill through the theoretical war rooms of the East. The Soviet military doctrine relied heavily on attrition. They knew their own manufacturing standards were often crude, favoring quantity over quality. A Soviet MiG-21 aircraft, if subjected to similar forces, would likely have suffered catastrophic structural failure. Its aluminum was softer, its rivets were less precise. The survival of the cornfield bomber suggested that American aerospace engineering possessed a hidden durability factor that Soviet calculations had missed. If American jets could crash land in enemy territory, be repaired, and fly again, the Soviet Union would need to shoot down every single NATO fighter 3 times over to win an air war. The recovery operation became a spectacle of American industrial might. The wings were unbolted, the vertical stabilizer was removed. The fuselage was lifted onto a flatbed truck and then transferred to a railroad car. It wasn't treated as scrap, it was treated as a patient. As the train carried the dismembered fighter back to McClellan Air Force Base in California, a new question arose, one that provided the true twist of this saga. Most assumed the airframe would be used for static testing, or perhaps a museum piece. It had, after all, ejected its pilot and sat in a field. It was bad luck. Pilots are a superstitious breed. No one wants to fly a plane that has already tried to kill its master. But the engineers at McClellan ignored the superstition. They looked at the data. They looked at the pristine condition of the avionics bays. They made a decision that defied all standard protocols for a Class A mishap. They were not going to scrap it. They were going to fix it. This decision was the ultimate act of technological arrogance. It was a message to the world. The repairs took months, not years. The crushed underside was patched with new aluminum. The internal wiring was checked and rechecked. The cockpit was fitted with a new ejection seat to replace the one Major Faust had used to save his life. By late 1973, the work was done. The aircraft, tail number 580787, was rolled out onto the tarmac. It didn't look like a survivor of a crash. It looked brand new. The paint was fresh. The engine roared to life with the same ferocity it had shown over Montana. But there was a lingering doubt. A machine is more than just metal. It is a balance of forces. Had the crash introduced invisible microfractures? Would the wings shear off the first time it pulled 9 Gs in a dogfight? The test pilots who took it up for its recertification flights reported something unsettling. The plane didn't just fly, it flew better. The alignment of the flight control surfaces, painstakingly reset by the repair crews, was more precise than it had been coming off the factory line. The cornfield bomber was tighter, faster, and more responsive. It was returned to active service. This was the twist that no Soviet analyst could have predicted. The very same aircraft that had humiliated its pilot and baffled the laws of physics was now back on the front line. It was assigned to the 49th Fighter Interceptor Squadron. It was flying combat air patrols again. It was intercepting Soviet Tu-95 Bear bombers off the coast. Imagine the psychological impact on a Soviet bomber crew. They are flying a long-range patrol, testing the American defenses. They see an F-106 aircraft rise to meet them. They track its tail number. If their intelligence was good enough, they would realize that this was the ghost plane. This was the machine that refused to die. It was a zombie interceptor, risen from the grave to hunt them down. But the story was not over. The plane had returned to the sky, but the mystery of why it had landed itself was about to be solved. As the engineers and mathematicians pored over the flight data to understand the aerodynamics of the event, they stumbled upon a revelation about the Delta Dart's design and a secret flaw in the pilot's training manual that changed how every fighter pilot in the US Air Force would be taught to handle a spin. The plane had not landed because of a miracle. It had landed because of a specific, counterintuitive interaction between the trim tabs and the center of gravity that occurred only when the cockpit was empty. The shock was not that the plane was smart. The shock was that the pilot, by trying to save the plane, had actually been the one crashing it. The ultimate revelation of the cornfield bomber incident was not found in the snow of Montana, nor in the repair hangars of California. It was found in the sterile, fluorescent-lit rooms of the Accident Investigation Board, where aerodynamicists and mathematicians stared at the flight data until the impossible truth emerged. For the Soviet analysts watching from across the Iron Curtain, this truth was the most unsettling aspect of the entire affair. It challenged the fundamental philosophy of aerial warfare that had dominated the 20th century, the belief that the pilot is the master and the machine is the servant. The shock was a blow to human ego. The investigation concluded that the 580787 did not land despite losing its pilot. It landed because it lost its pilot. The physics of the event revealed a cruel irony. When Major Gary Faust was wrestling with the controls, pulling the stick back and fighting the spin, he was inadvertently preventing the aircraft from recovering. The F-106 Delta Dart, like many Delta Wing aircraft, suffered from a condition known as deep stall or superstall. In this state, the turbulent wake from the main wings blankets the tail surfaces, rendering the elevators useless. The more the pilot pulls back to raise the nose, the deeper the stall becomes. It is a death spiral, a trap of aerodynamics where human intuition, the desire to pull up away from the ground, is the exact wrong input. But the moment Faust initiated the ejection sequence, the variables of the equation changed violently. The ejection seat of an F-106 aircraft is propelled by a rocket motor that generates tremendous thrust. As the seat blasted upward, the equal and opposite reactions slammed the nose of the aircraft downward. This was not a gentle nudge, it was a hammer blow of force directly to the airframe. Simultaneously, the center of gravity shifted. The departure of the pilot and the heavy ejection seat moved the aircraft's balance point. The trim tabs on the elevons, which Faust had set for takeoff and maneuvering, were now acting on a lighter, different machine. The violent downward kick from the rocket broke the stall. It pushed the nose down just enough for clean air to flow over the wings again. The Delta wing, a design masterpiece of the 1950s, naturally wanted to fly. Freed from the interference of the desperate pilot trying to force his will upon it, the machine found its own equilibrium. It trimmed itself for a glide speed of 175 knots. It became a perfect glider. For the Soviet Union, this reality was terrifying because it suggested that American technology had achieved a level of inherent stability that Soviet engineering could not replicate. In the Soviet Air Force, the MiG-21 aircraft and the later MiG-23 aircraft were notoriously unforgiving. They were pilots' planes, requiring constant, aggressive management. If a Soviet pilot let go of the stick in a spin, the plane would kill him. The idea that an American interceptor was designed with such aerodynamic genius that it could correct a human error by simply being left alone was a strategic shock. It implied that the Americans were building safety margins that the Soviets couldn't afford. It reinforced the technological gap narrative. While Soviet factories were churning out thousands of crude, expendable fighters, the Americans were building complex, resilient machines that refused to die. The story of 580787 did not end with its return to service. The Lazarus machine had a second life that was just as extraordinary as its resurrection. After the repairs were completed at McClellan Air Force Base, the aircraft was not retired to a training unit or hidden away. It was sent back to the front lines. It served with the 49th Fighter Interceptor Squadron at Griffith Air Force Base in New York. For years, it stood alert on the tarmac, fully armed with nuclear Genie rockets, ready to launch at a moment's notice to intercept Soviet Bear bombers over the Atlantic. The pilots of the squadron knew the tail number. They knew the legend. There is a psychological weight to strapping into a cockpit that has already been empty in flight. Some called it the cornfield bomber, others called it the glider. But they all respected it. It flew with a straightness and a reliability that seemed to mock the very idea of a crash. Major Gary Faust, the man who had ejected, also survived his brush with death. He returned to flight status. Years later, in a moment of poetic closure, he was reunited with his old ship. He did not fly it again, but he visited the squadron. He walked up to the grey flank of the 580787, ran his hand along the aluminum skin that had slid across the Montana ice, and looked into the cockpit. It was a meeting between two survivors, the man who had given up and the machine that hadn't. By the 1980s, the F-106 aircraft began to age out of the inventory, replaced by the F-15 Eagle aircraft. Most of the Delta darts were converted into QF-106 drones, remote-controlled targets designed to be shot down during missile tests. It was a dignified but destructive end for the fleet. They were painted orange, flown by computers, and blown out of the sky by the next generation of weapons. But 580787 was different. The Air Force recognized that this specific airframe was special. It had earned an exemption from the firing squad. In August of 1986, the Cornfield bomber took its final flight. It was not a combat mission, it was a ferry flight to Wright-Patterson Air Force Base in Dayton, Ohio. The pilot touched down, taxied to the ramp, and shut down the engine for the last time. The technicians who received it were stunned by its condition. After a crash landing, a resurrection, and decades of high-G maneuvering, the airframe was still straight. The avionics were still functional. It was rolled into the National Museum of the United States Air Force. Today, if you walk through the Cold War gallery of that museum, you will see it. It sits quietly in the shadows of the massive bombers and sleek spy planes. It looks like just another fighter jet. But if you look closely, you can see the faint ripples in the metal, on the underside of the wings, the scars of its journey through the snow. For the visitor, it is a cool story. But for the historian of the Cold War, it is a symbol of the ultimate American advantage. The Soviet Union collapsed, not just because of economics, but because they could not compete with a system that could turn a disaster into a triumph. They could not defeat an enemy whose planes could land themselves. The Soviet pilots who heard the rumors of the self-flying plane in 1970 were right to be baffled. They were witnessing the dawn of a new era of warfare, where the silicon and the aluminum were becoming more capable than the flesh and blood in the seat. The cornfield bomber was the grandfather of the modern drone, a premature glimpse into a future where the pilot is optional. In the end, the mystery was solved, but the wonder remains. On that cold February day, a machine defeated its own destruction. It refused to be a statistic. It proved that sometimes, the best way to fly is to simply let go. The Cold War impact is often measured in megatons and treaties, but sometimes it is measured in the silence of a Montana field, broken only by the steady, defiant idle of a jet engine that didn't know how to quit.